Hello there guys, how's it going? Mike coming back at you with another video on Precalculus. And today we are beginning a new chapter, but more importantly, I am coming to you guys from the new document camera. Things getting more exciting as every class goes on. But today we are going to get into trig. We're going to start off with some of the basics though. We're going to talk about angles and radian measure. So an angle, I'm sure you guys have all seen these things before. This is probably going to be a little bit of a trig review here, mildly. But an angle is formed by two rays, one called the initial side, the other called the terminal side, and with a common endpoint called the vertex. And here you see I have an angle drawn right here. This right here is my initial side. This side right here being my terminal side. And how can we tell that which side is the starting side and which side is the terminal side? We can tell because usually we draw an arrow like this telling us where we start and where we end. So that's how we know what is our initial side and what's our terminal side. And this point right here, this is our vertex. So we say that an angle is in standard position if its vertex is at the origin and the initial side is on the positive x-axis. So as I sketch my coordinate plane here, and my angle in red here, this would be an example of an angle here that's in red. This is an example of an angle that is in standard position. The vertex, where those two rays meet, is at the origin. And after drawing that red arrow there to show what our angle looks like, where it starts and where it ends, we see that the starting side is on the positive x-axis. This is how we'll be working with all of these angles in our course. You're never really going to have to worry about an angle not being in standard position. This is more just a definition so that you see what this thing is. So angles can either be negative or positive. Positive angles are generated by taking your starting side and then moving counterclockwise with it, while negative angles are formed by taking your starting side and rotating it clockwise. This angle in red here, this is an example of a positive angle. We started on the positive x-axis and then we rotated counterclockwise to reach our terminal side. An example of a negative angle, if I draw a new set of coordinate axes here, this angle's in purple. This would be an example of an angle that is negative. We started on the positive x-axis and then we rotated clockwise to get to this terminal side here. So counterclockwise is positive, counterclockwise, my apologies, counterclockwise rotation means positive, clockwise rotation means your angle is negative. When we talk about an angle, we will often refer to the quadrant that the angle lies in. What does it mean for the angle to lie in some particular quadrant? Whatever quadrant the terminal side of the angle is in, that is the quadrant that we say the angle lies in. Just as a quick recap of what are the four quadrants of the XY plane. Up here, starting in the upper right hand corner and then going counterclockwise, 1, 2, 3, and 4. So looking back at our two samples here, our red angle here, this is our terminal side. The terminal side lies in quadrant 2, so we would say that the angle is in quadrant 2. This angle that's in blue here, or purple, the terminal side lies in quadrant 3, so we say that the angle would lie in quadrant 3. Just some basic trig things here to get ourselves started off. There are two ways that we can measure angles, and we can describe these angles. The first way, probably the most common way, the way that we all know of, measuring angles in degrees. And then we have the various types of angles. These terms should be familiar as well from previous math classes. Because our angle is small and positive, we think it's very cute. So we say it's a cute angle. Not really, but yes. And a right angle, or an angle that measures exactly 90 degrees, an obtuse angle between 90 and 180, and then a straight line or a straight angle, an angle that measures exactly 180. We don't have necessarily a term for an angle that measures greater than 180, although personally I think there should be one. The other way that we measure angles, or the way we can measure angles, and this one may be less familiar to some folks, is in radians. Now, what the heck is a radian? A radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. Now, that is a very complicated definition. Personally, I think that's a crappy definition. But nonetheless, it really is the best one realistically. Although it is really crappy, it is kind of the best one out there. But don't necessarily think of that being the only definition of a radian. We're not so concerned about what the definition is. That's not crucial in the world of math. The main thing, the very important thing to know with radians is how to find the radian measure of an angle. So if you are given the length of an arc in a circle, a portion of the circumference of that circle. If you know the length of your arc, which is given by S, and you know the radius of your circle, which is given by R, then the radian measure of any arc is given by this formula right here. Theta equals S divided by R. So from this formula, theta equals S over R, we get some fairly basic yet standard types of problems that just make sure you know this formula that you have here. So gonna kick it off with one here. An arc of length 20 is intercepted by an angle measuring 7 radians. What is the radius of that circle? So we're just going to pick out the pieces of information that we know. You'll know 2 of S, R, and or theta, and you'll have to find that third one. So we are given the arc of length 20. That's the length of that arc that's intercepted by our angle. So S here is 20. It says it's intercepted by an angle measuring 7 radians. So in this case, we know theta. We know the angle measure of this thing. Theta here is equal to 7. So what is the radius of the circle? Well, we just use our basic formula, theta equals S over R, and we calculate what R is. Theta equals S over R. Well, to solve for R and to get R all by itself, I need to multiply both sides by R. So S equals R times theta. And then I'm going to divide both sides by theta to get R equals S over theta. And now just substitute in your values. S is 20 and theta is 7. So R is 20/7. And if it specified a unit like inches or feet or whatever, you would include your unit as well. Another problem here that's very similar, same type of problem overall, just we're finding a different thing here. A circle of radius 6 has an angle measuring 3.2 radians. What's the length of the intercepted arc? Once again, we are going to just point out or isolate the key pieces of info that we need, and we're going to substitute them into our formula. The circle of radius 6, so R is equal to 6, has an angle measuring 3.2 radians. Again, we are given theta here, 3.2. From our previous problem, we saw that S is equal to R times theta. S is what we're looking for, so let's just substitute R and theta into that formula, and we'll come up with S. So we get 6 times 3.2, and that is equal to 19.2. Again, if there was a unit provided, you would include your unit as well. But those are just really basic, really straightforward problems to just get you practice with finding measurements of portions of circles or aspects of circles involving radian measure. I think it's pretty straightforward then, just given our formula right here. Theta equals S over R. If you're given S and R, you should be able to just plug those things in and you can find theta. But the key thing is you have to be sure that when you do these problems, your angle is given to you in radian form. I may try to trip you up and give you the angle measure in degrees, and if you use it in that form, you're not going to come up with the correct answer. So the question is, given these two forms, degrees and radians, how do we switch between the two? Well, first, I don't think it's a mystery that there are 360 degrees in a circle. I'm pretty sure that's all standard knowledge by now. So I want to find what is the radian equivalent of that. So theta being S over R, S for a whole circle, what's the length of the intercepted arc of the whole circle, is just saying what's the length of the outside of that circle, aka what is the circumference. The formula for circumference is 2 pi r, not to be confused with the area formula, which is pi r squared. So circumference equals 2 pi r divided by r, the r's cancel out, and you're left with 2 pi radians. So 360 degrees equals 2 pi radians, or 180 degrees equals pi radians. So we have a little connection between these two things that we can now utilize to convert from one form to the other. So if you're going to go from degrees to radians, you're going to take your given number and you're going to multiply it by pi over 180. When you're converting to radians, you should always have a pi left over in your final answer. There should always be this pi symbol there. If you're going to go from radians to degrees, you're going to take your angle that's in radian measure, which is going to have a pi in it, and you're going to multiply that by 180 over pi. When you multiply it by 180 over pi, then the pi's are going to disappear. They are going to vanish. So let's do some sample problems there, switching between these forms. So first up here, we're going to convert 57 degrees, negative 120 degrees, and 500 degrees into radians. And the idea here is that after you've made the conversion, after you've done the proper multiplication, you simplify these things as much as possible. So 57 degrees, guys, it doesn't matter what angle measure you are given. It could be 57, it could be negative 10,000, it could be 100, it could be positive 172,000. You're always taking that measure that's given to you, you're multiplying it by pi over 180, and then you're going to simplify that. So for 57, it is just 57 times pi over 180. That gives me 57 pi over 180. And this is equal to 19 pi over 60. Really simple, really straightforward calculation. For negative 120, it's just going to be negative 120 times pi over 180. Or negative 120 pi over 180, and this is equal to negative 2 pi over 3 in the end. Those two numbers on the top and bottom each contain a common factor of 60, which we can pull out and then cancel out. So pause the video here and on your own convert 500 degrees to radians and see what you come up with. So press pause now. When you think you have the answer, press play, and we will see if you are correct. All right, so let's see if you had the correct answer. 500, this is going to be 500 pi divided by 180, and this is equal to 25 pi divided by 9. There's a common factor of 20 between the terms on the top and bottom, and you can pull that out and cancel it. So this is converting to radians. Again, you can see that in every one of these answers, there is a pi showing up there. That is what we are looking for. Let's get some practice converting from radians. So we're given things that contain pi. And we're going to change it to something that does not have pi in it. So first up is 5 pi over 12. Remember, when we convert from radians, we're multiplying the thing by 180 over pi. And we're doing this so that the pi's cancel out. You don't want pi's left over in your answer when you're converting from radians. So the pi's cancel out. And if you did 5/12 times 180, you could check this in your calculator, or if you're that good with mental math, you can do it in your head, but you come up with 75 degrees. 180 divided by 12 is 15. 15 times 5 is 75. If we go negative 7 pi over 10, again, multiplying by 180 divided by pi. Again, the pi's cancel out. 180 divided by 10 is 18, and then negative 7 times a positive 18 gives us a negative 126 degrees. So that is our degree measure of this angle here. Pause the video now, and then on your own, try to convert 23 pi over 2 into degrees. So once you think you have the answer, press play, and we'll see if you are correct. All right, so let's see if you came up with the correct answer. 23 pi divided by 2 multiplied by 180 over pi. Again, the pi's cancel out. 180 divided by 2 is 90. And if you do 23 times 90, you get 2070 degrees. So there you go, guys. Really basic calculations in terms of switching between degrees and radians there. Now, unlike points in the xy plane, angles are not unique in the sense that there is more than one way to get an angle that has the same terminal side and it travels in the same direction. Basically, we have actually an infinite number of angles that act identically to each other. And angles that act in this way, angles that don't have the same measure but act identically to each other, are referred to as coterminal angles. A coterminal angle is an angle that is an integer multiple, that is to say whole number multiple, of 360 degrees, or 2 pi radians, more or less than your given angle theta. So if you're given an angle theta and you're asked to find angles that are coterminal to it, if I'm looking for an angle that is in degrees, you're simply going to add or subtract 360 onto it, and you'll get a new angle. If it's in radians, if I'm looking for an answer in radians, you're going to add or subtract a whole number multiple of 2 pi onto that angle. But here's one basic sample that I have here. If I want to find angles coterminal to 30, I'm just adding or subtracting 360 onto it. So if I add 360 onto 30, I get 390. If I add another 360 onto that, that gets me 750. If I added another 360 onto that, that would get me 1,110 degrees. Then I went the opposite way. If I subtract 360 from 30, I'll get negative 330. If I subtracted another 360, I would get negative 690 degrees, and I can keep going on that way, so on and so forth. So really, really easy to find angles that are coterminal to a given angle. You're just adding or subtracting 360s or 2 pi's onto your given angle. So we'll do a couple more samples here. First off, we're going to find 4 angles that are coterminal to 53 degrees. Write your answers in degrees. If I don't specify what way I want your answer in, your choice. But 53 is a relatively nasty number. You don't really want to try to convert that into radians and then write answers in radians there. So we start off with 53. Let's take 2 positive coterminal angles and 2 negative coterminal angles. So let's start off with the positives. If I add 360 onto this guy here, that's going to give me 413. And then if I add another 360 onto that, that is going to get me 773 degrees. We could keep going on more and more if you wanted. If you did another 360, that would get you 1,133 degrees. But let's go to the negatives. I'm going to subtract 360 from this 53. It's going to give me negative 307 degrees. And then if I subtract another 360, that's going to give me negative 667 degrees. So there we go, guys. We have 4 coterminal angles to 53. 2 negative and 2 positive. Second one here, a little bit more involved, a little bit more challenging, a little bit more work that has to be done. We're going to find 4 angles that are coterminal to 80 degrees, but this time write your answers in radians. So if you see a question like this, my first suggestion would be to take your given angle and write it in radians. So 80 degrees is equal to 80 pi divided by 180, which is equal to 4 pi over 9. So that's the radian measure of my given angle. Now I need to add or subtract multiples of 2 pi onto this thing here. And you do have to write these things in one fraction. You can't just write 4 pi over 9 plus 2 pi, 4 pi over 9 plus 4 pi, things like that. You do need to write your answers in each one in a single fraction. So in terms of ninths, what is 2 pi? 2 pi is equal to 18 pi over 9. So I'm going to be adding or subtracting this quantity onto 4 pi over 9, and that is going to give me my coterminal angles. So starting off with my given angle, once again, let's go 2 positive coterminal angles and 2 negative coterminal angles. If I add 18 pi over 9 onto the 4 pi over 9, I'm just adding the numerators. So that's going to give me 22 pi over 9. And if I add another 18 pi over 9, it's going to give me 40 pi over 9. All right, there's my 2 positive coterminal angles. Now let's go negative. I'm going to subtract 18 pi over 9. That gives me minus 14 pi over 9. And then subtract another 18 pi over 9. That's going to give me negative 32 pi divided by 9. So there we go, guys. There are our 4 coterminal angles to 80 degrees, but this time our answers are given in radians. So not too complicated of a calculation that you have to do there for that guy. Just a couple concepts, just things I want you to have seen that are out there. This is just a quick little wrap up of this video. Linear and angular speed. For a point that's in a circular motion, so some object is, say, spinning on some point, it moves in a circular motion. If the circle has a radius r and the object makes an angle of radian measure theta in some time t, its linear speed is given by r times theta divided by t, and then the angular speed is given by theta divided by t. This guy right here, that is not a w, that is the Greek letter omega, and that's the lowercase Greek letter omega, not the capital. And just as a relationship between the linear and the angular speed. The linear speed v is equal to the angular speed omega times the radius. Not something that you're really going to see from me, but just note that it's out there. So guys, this concludes our video on angles and radian measure, how to convert between these two forms, what these things are, the big formula, theta equals S over R here up at the top. That is a very important guide to know. Guys, if you have any questions or comments, please be sure to reach out to me, send me emails, texts, phone calls, rocks through my window. Try to shout very loud. See if you reach me. Otherwise, until the next video, take it easy.